Hi everyone, we have learned our first data structure in DSA array. Now let's solve a problem. Our first problem is write a code to reverse an array. If my input is 1, 2, 3, 4, then the reversed array will be 4, 3, 2, 1. Or if my input is A, B, C, D, then the reverse array will be D, C, B, A. Let's first solve it using the naive approach, which is using an extra array. Let's take an example. Let's say variable A is our array 1, 2, 3, 4 till 10. The reverse array would be 10, 9, 8, 7 till 1. Now I'll loop through the first array from last index. If the first index is 0, then the last index will be 9. I will read the last number and add it to the new array. Then move to the second last number. Then to the third last until I reach index 0. So the new array becomes 10, 9, 8, 7 till 1. And voila, this is our reverse array. Let's calculate its time and space complexity. We loop through the array once, so the time complexity is O of n. We use an extra array of the same size. Therefore, space complexity is O of n. If we have 1,000 elements in the array, then we need the array of size 1000. This method is simple but not space efficient. Let's think a little more. Let's look at the second approach, 2 pointers. We will use the same array as an example, but this time we don't want to use an extra array. Pause the video and think about it. Treat it like a puzzle. How can we solve this problem without an extra array? I have already given you a hint. We will be using 2 pointers. Now here is the idea. We use 2 pointers. One at the start, we will call it as a left pointer, and one at the end, we will call it as a right pointer. Let's also write down their indexes. Now we swap the elements. The first element is 1 and the last element is 10. After swapping, 1 becomes 10 and 10 becomes 1. Now we move both pointers. Left pointer moves from index 0 to 1 and right pointer moves from index 9 to 8. Next, swap 2 and 9. Then swap 3 and 8. Then swap 4 and 7. And finally 5 and 6. Now what? The array is reversed. But how does our code know when to stop? If we keep going, we might swap the same value again. So here is our break condition. We stop when left pointer is not less than right pointer. That means if left pointer is greater than right, then stop. Also, it means if left pointer is equal to right pointer, then stop. When our array is odd size, both pointer will meet at the middle. There's no need to swap the same element with itself. So our break condition is left should be less than right. Now let's check time and space complexity. We still loop through the same array, but only half of it because we are swapping 2 at the same time. So technically it is half of O of n. But we ignore constant. Therefore, time complexity will be O of n. And we don't use an extra array. just the temporary variable. So space complexity will be O of 1, that is constant. Now let's write the code in Python using Jupyter. We'll create an array A is equal to 10, 20, 30 and 100. Now let's write a code for the first method. Using an extra array, we will create an empty array and keep adding reversed elements. We calculate the length of the array first and then write a loop from 0 to the length. Let me print what the index looks like. It starts from 0 to 9, but I want to loop in reverse from 9 to 0. So I'll subtract the index from the length. Now it prints in reverse. It starts from 1, so I will subtract 1 more. Now it's printing the correct indexes in the reverse. So let's print the corresponding numbers too. Yes, the array is printing in the reverse. Now we will append these numbers to our new array. And here we have reversed array. Now let's convert this into a function. I'll copy the code. Remove print statements, indentation, and return the array. Done. Let's test the function. I'll copy this and run. Yes, works perfectly. I will add few numbers and again run. Yes, perfectly. Even we change the size array and use odd length, it still works. Okay, now let's write a code for the optimized method 2-pointer. I will use the same array. Let's calculate the length. And we will assign two variables, left and right. Left is equal to 0 and right is equal to length minus 1. Then we write a while loop while left is less than right. Let's print the values to check if it's working. Yes. So first I am printing all the left and second I am printing all the right, and eventually my left number will swap with my right number. So 10 will swap with 100, 20 will swap with 90 and so on. And if I increase the size to make it odd, then also 10 will swap with 101, 20 will swap with 100, and 60, there is no 60, so 60 won't swap with any number. And yeah, this is perfect. This is what I want. So let's write a logic to swap this both number. I will store the value of the left element in the temp variable. A of left is equal to A of right, and in the right I will store the number which I have stored in the temp earlier. Okay, yes, now it is reversing correctly. Let's convert this code into a function. I will copy the code, delete unwanted print statement, indentation, and return the array. Let me run the code. 3, 4, 5, 6, 7, and yes, it is working perfectly. Yes. So that's it. We have seen naive method using an extra array, optimized method using 2 pointers. Thank you for the watching till the end. See you in the next video. Bye bye.